Geothermal power is reusable because its fuel source comes from rainwater and snowmelt that seep into underground reservoirs that are heated by the Earth's mantle. As the rainwater or snowmelt becomes heated, it becomes a superheated fluid. A geothermal power plant uses what is called a surface well to pull water up from the reservoir through crystallizers that turn it into steam, and then injects the remaining liquid back into the reservoir. This is how it is reusable.
As the liquid gets closer to the surface, the pressure is reduced. Because of this, a small amount of fluid in the well will turn or flash into steam. A combination of superheated fluid and steam flows from the pipelines to a wellhead separator. The pressure of the superheated fluid decreases in a high-pressure crystallizer, causing most of the superheated fluid to vaporize quickly and flash into high-pressure steam. The geothermal fluid that did not become steam flows through standard pressure crystallizer, where more steam is produced. This is where an extra amount of the standard pressure steam could be created. The flashing continues to occur in a low-pressure crystallizer. After this, all of the remaining fluid that has yet to be flashed is piped to a low-pressure crystallizer, or it will produce low-pressure steam.
Next to the crystallizers, there is a large or several large turbines depending on the size of the geothermal power plant, and out of the wellhead separator, the high standard and low pressure crystallizers are pipes which transport all of the steam collected by them to the turbine or turbines. Inside of the turbines there are large fans which, when they come into contact with the steam from the crystallizers and wellhead separator, force the blades to spin. After this process, the steam is then let out through a ventilation system, and the spinning blades are attached to a spinning centerpiece rod, which also spins. The center rod that is then forced to spin is connected to magnets inside an electrical generator. The spinning of these magnets near the other magnets is what creates the electricity.
Electricity generated in the turbine is directed to a step-up transformer where it is then sent to power lines.
Once again, geothermal energy is produced when an underground reservoir is heated by the Earth's magma, pumped up to the surface, pushed through the crystallizers and back into the reservoir, and then reheated by the Earth's core. This way it is reusable, green, and could potentially last a much longer period of time. However, the resource can run dry if too much water is pumped out of the reservoir faster than it can be refilled. Therefore, you need to put more water into the reservoir than you are pulling out, therefore keeping the reservoir filled. Now, if this did become a major source of power, you could potentially have facilities that sole purpose was to pump liquid back into the reservoirs. Once again, geothermal energy is much more clean and renewable than coal, because coal gets used and then used up more and more until there is nothing left. However, a geothermal energy supply with proper care could continue working, whereas coal simply cannot.